Formal definition and core principle. Call by value CBV means the called function receives its own copy of the argument's value. The original variable that lives in the caller's scope never changes because the function works on a separate memory cell. Call by reference CBR means the called function receives a reference or alias to the original variable. Any write to the parameter inside the function actually writes to the caller's variable because both names point to the same memory location. Think of call by value like photocopying a paper and handing the friend a copy. The friend can scribble on the copy without affecting the original. Think of call by reference like handing the original paper to the friend. Any mark the friend makes appears on the original. Memory layout stack copying versus address binding. In most languages, a function call creates a stack frame that holds its local variables. CBV, the compiler, generates code that copies the argument's bits from the caller's frame onto the callie's frame. The new copy occupies its own space on the stack. CBR, instead of copying the whole value, the compiler stores the address, a pointer of the caller's variable, in the callie's frame. The callie's parameter slot contains just a pointer, usually 4 or 8 bytes, that points back to the original stack slot or heap object. Analogy: CBV is like moving a suitcase, the whole thing, into a new room. CBR is like leaving the suitcase in the first room and giving the new room a key to open the same suitcase. Impact on original arguments, before and after state analysis. Before the call, let a equals 5 in the caller. CBV call, whoever receives a local copy, a prime equals 5. Inside foo we may do a prime equals a prime plus 3. The caller's a stays 5 after the function returns. CBR call, bar of ampersand or bar of ref a receives a reference to the same storage. Inside bar we do star p equals star p plus 3. After return the caller's a becomes 8. The change or lack of change can be demonstrated with a table. Caller before vertical bar, inside function vertical bar caller, after CBV vertical bar caller, after CBR. 5 vertical bar 8 vertical bar 5 vertical bar 8. Thus, CBV guarantees no side effects on the caller's variable unless the function explicitly returns a new value, while CBR allows side effects by design. Explanation: behavior with primitive types versus composite data structures, arrays, structs. Primitive types int, char, float, etc. are typically small. In call by value they are copied byte by byte. In call by reference a pointer to the primitive is passed. Composite types, arrays, structs, objects can be large. Many languages implement call by value for these by copying the whole structure, which can be costly. To avoid that cost, languages often default to call by reference like semantics. The function receives a reference to the original data. The C code example defines a function modify int that takes an integer x and sets x to 10. This is call by value, caller unchanged. It also defines a function modify r that takes an array and an integer n and sets it at index 0 to 10. The array decays to a pointer, making it call by reference like. In Java, all object variables hold references. Passing an object is always by value of the reference. The reference itself is copied, but it still points to the same object. Primitive values are still passed by value. Thus, for primitives the distinction is obvious. For composites, the language may hide the copying behind a reference to keep performance reasonable while still technically following its own parameter passing rule. Computational cost analysis: time and space of each passing method. Copying a value of size k takes big O of k time. Passing a reference takes big O of 1 time because only the address constant size is moved. CBV allocates a new memory region of size k in the callie's stack frame. CBR allocates only a pointer, usually 4 or 8 bytes regardless of k. If k is small, for example, a 32-bit integer, the cost difference is negligible. If k is large, for example, a 10-megabyte array copying can dominate runtime and may cause stack overflow, while a reference costs a fixed tiny amount. Data size: CBV time, CBR time, CBV stack space, CBR stack space. 4 bytes big O of 1, big O of 1, 4 bytes, 8 bytes pointer. 1 kilobyte big O of 1 kilobyte, big O of 1, 1 kilobyte, 8 bytes. 1 megabyte big O of 1 megabyte, big O of 1, 1 megabyte, 8 bytes. Therefore, exam questions often ask you to compare these costs and to decide which method is preferable for a given scenario. C: by default arguments are passed by value. To achieve reference semantics, you must explicitly pass a pointer int star p or use ampersand to take the address. Structs are also passed by value unless you pass a pointer to them. C++ supports both call by value and call by reference, plus reference parameters in ampersand r. When you write void f in ampersand x, the compiler passes the address under the hood, but the syntax looks like a normal variable. C++ also has move semantics C++11, which complicates the picture, but the classic exam focus stays on value versus reference. Java: pass by value only, but the value of a variable that holds an object is a reference. So primitive types are truly copied, while object references are copied the reference value, not the object. This leads to the common phrase pass by value of the reference. Python: arguments are passed by object reference, sometimes called call by object reference or call by sharing. The reference itself is passed by value. The function receives a new name bound to the same object. Mutating the object, for example list.append, is visible to the caller. Rebinding the parameter to a new object is not. Exam tip: always state the language rule first, then illustrate with a short code snippet. Mathematical illustration of value copying versus reference aliasing. For example, f of x equals x squared. Let a mathematical function f be defined as f of x equals x squared. Call by value. The caller supplies a number a. The function works on an independent copy x equals a. Computing x equals x plus 1 inside the function changes x to a plus 1. But the caller still has a formally. After the call, we have a prime equals a and return equals a plus 1 squared if we return the result. Call by reference. The caller supplies a variable a that can be thought of as a mutable storage cell. The function receives an alias x with a, and assignment x equals x plus 1 is actually a equals a plus 1. So after the call, the caller's variable becomes a prime equals a plus 1. The returned value f of x is computed with the updated a. In notation, call by value, let a sub-zero be initial value. Inside f, x equals a sub-zero, x becomes x plus 1, which yields x equals a sub-zero plus 1, return a sub-zero plus 1 squared. After a equals a sub-zero, call by reference, let a sub-zero be initial value. Inside f, alias x with a x becomes x plus 1, which results in a equals a sub-zero plus 1, return a sub-zero plus 1 squared. After a equals a sub-zero plus 1. This formalism shows how the state of the original variable diverges between the two passing strategies. Typical exam questions, answer outlines, and common pitfalls. Given the C function void inc taking an int pointer p that increments the pointed value, and the call int x equals 5 inc address of x, what is the value of x after the call? The argument is a pointer, so inc receives a reference to x. The statement increments the memory location of x, hence x becomes 6. Confusing the pointer value, the address, with the pointed to value. Some students write that the address changes. Explain the difference between Java's void change taking an int a that sets it to 10, and void changeObj taking a point p that sets p.x to 10. When called with int v equals 5 change v and point pt constructed with 5 changeObj pt. Int is a primitive, Java passes its value so v stays 5. Point is an object, the reference is passed by value, but both caller and callee refer to the same point object, so pt.x becomes 10. Saying Java uses pass by reference for objects, the correct phrase is pass by value of a reference. Write the time and space complexity of passing a 10,000 element array to a function in C using call by value versus using a pointer. Provide the big O notation. Call by value copies 10,000 elements, which is O of n time and O of n additional stack space. Using a pointer is constant time, O of 1, and constant additional space. Forgetting that the pointer itself still occupies constant space, students sometimes claim 0 additional space. In Python, what will be printed? Define function f with parameter lst. Inside, lst equals lst plus a list containing 4, then lst append 5, then print lst. Then L equals list 1, 2, 3. Call f with L, then print L. Inside f, lst equals lst plus 4 creates a new list, then appending 5 mutates that new list, so it prints 1, 2, 3, 4, 5. Outside, L is unchanged, so it prints 1, 2, 3. Assuming plus mutates the original list, it actually creates a new one. Common pitfalls across languages. Mixing up copy of the value with copy of the reference. Assuming that a function cannot modify a caller's data in a language that uses reference semantics for objects. Ignoring that large structs or arrays passed by value may cause stack overflow. Forgetting that const qualifiers in C or C++ affect whether a reference can modify the original. In Java, believing that reassigning a parameter p equals new point changes the caller's variable. It does not, because only the reference value is copied.